live from Earth. It's Space Radio. This is Paul Sutter, and coming up, we're talking about a wet Mars after all. And of course, taking listener questions about all things in this amazing universe, because that's exactly what this show is about. We record every Thursday at 8 p.m. Eastern, and you can follow along online or leave a voicemail at spaceradioshow.com. And in today's Blue Shift, I'll be talking about Ready to Launch. But first, the news. Aha! Hello, Space Cadets. Welcome to Space Radio. I'm Paul Sutter, astrophysicist at Stony Brook University and the Flatiron Institute. And for the next half hour, your agent to the stars. We got an amazing show for you today. I guarantee it is going to be slightly more coherent than the presidential debates. This show lives on listener questions. We record every Thursday at 8 p.m. Eastern here in Spaceman Studios in New York City. So leave a voicemail at spaceradioshow.com to get your question on the air. And also, you can follow along live with our Space Cadets tuning in from around the world, including but not limited to Halifax, England, Green Bay, Wisconsin, go Packers, Pell City, Alabama, London, UK, Dumas, Mississippi, Washington, D.C., and more Hamburg, Germany, checking in from Mars. I don't believe that. But hey, you send questions over that Space Cadet crew on the live streams, and I will do my best to answer them. Seriously, folks, I've only prepped 10 minutes of show material tops. So get those questions in. Austin, Texas, Howell, New Jersey, Warsaw, Poland. Amazing crowd tonight. And I need my timers because this is the radio show and this is going to be a good time. I promise. It's going to be a good time for me. I don't know about any of you, but for me, it's going to be pretty nice. Before I start taking questions, I wanted to share some interesting bits of news I caught recently. And a couple weeks ago, it was all about life on Venus. And we got a nice, solid rant. I'm not going to return to that subject for a while. But I do want to talk about water on Mars. Water on Mars is one of those things that's been on again, off again for over a century. Right? Remember the canals on Mars that turned out to just be an optical illusion from our horrible telescopes at the time? I mean, they were good for the time, but now they're not so great. And then more recently, there were these like the crater walls that during the summer would look wet and then they would go away. That turned out not to be a thing. And the latest in the water on Mars journey has to do with subglacial lakes. These are apparently lakes sitting underneath a mile of ice at the southern pole of Mars. Now, the astronomers who did this study, they first announced this a couple years ago where they thought they saw one lake underneath the southern ice cap of Mars. And now they went back, they did it again, and they got more data. And then they're like, oh yeah, there isn't just one, there's like 4 of them. And the biggest one is like 30 kilometers across. It's like decently sized. So how they got this data, how they got this measurement was there's an orbiter, the Mars Express orbiter, run by the European Space Agency. It's got a radar on it, and they bounce the radar off the surface, and radar can punch through ice and then hit the ground and then come back up. But if there's something between the ice and the ground, there'll be a different radar signature. There is something highly reflective to radar. This group and a bunch of astronomers claim that this is the signal of water. But to make water, you need it to be warm. And so that is the big question here, is how does it get warm enough underneath the ice to stay liquid? Mars is a tiny bit warm, and like the ice itself is like a decent enough thermal blanket, but that's not quite enough. This water, if it is liquid, would have to be incredibly briny, like up to 20 times saltier than the Earth's ocean. So if you're excited about potential life, like that kind of salt, that's more like if you want to make pickles, Mars is a great place, but not so much a great place for life if the water really is that salty. But then how does it stay? Even then, there are questions about how does it stay warm enough to be liquid? And so that's where there's a lot of questions about this research. Like, yes, there is obviously something in this radar signal. They are seeing something, but some researchers or astronomers think it might just be a slush or a sludge, almost like a, I don't know, like a Slurpee, like an icy like material that is definitely not liquid, but also definitely not solid ice. It's somewhere in between. That way you only need a little bit of heat to keep it going, to keep it sludgy rather than liquid, and it might still give the same radar return. So it's up for debate. I'm not coming down hard on it like I came down hard on the life on Venus thing, because life is its own thing. Now we're just talking about liquid water. It's compelling evidence. It depends on your interpretation of the data, on whether you really think it's warm enough to support liquid water under that ice. If you don't think it's warm enough, then you don't get liquid water. And if you do think it's warm enough, you do get liquid water. And that's it. What is happening to my phone? Oh my gosh. Go, ew. I'm getting, an ad blew up on my timer. So that's the latest and greatest when it comes to space. It's time to have a conversation. Wow, did you guys hear that? That was annoying. I thought I bought this app so that wouldn't annoy me. I need some questions here. Thank you again, Nancy Graziano, for wrangling the space cadets, firing up all those questions. But I haven't done a, where's my, speak pipe. There you are. You can go to spaceradioshow.com and get your questions in. So that's what I'm about to do right now. We've got a voicemail ready to go. Hey, Greg, wake up. Wake up. Hey, can you play the tape? Thank you. Greg, we love you.
Hey, Paul, I just want to say that I enjoy what you do and keep on doing what you do. So here's my question. Two people, person A and person B, in constant relative motion, pass each other in opposite directions in the void of space. So far, there is nothing that can distinguish who is actually doing the moving. Then, person A fires their jetpack thrusters to send them toward person B and catches up with person B. Why exactly does that symmetry breaking of their motion cause person A to have their time slow down relative to person B? Please elaborate.
This is a really fun question, Alan. Thank you so much for asking. It does get into the real guts and the mechanics of special relativity. We're talking about time dilation and length contraction, all these crazy physics that get in when you start talking about relativity. And things like, moving clocks run slow are easy to say. But then when you really, really drink the special relativity Kool-Aid, which you should, it tastes great, you find out that all motion is relative. All motion is relative. It depends on your point of view. Like, you can be moving, but perfectly valid, you can say, no, I'm standing still and the rest of the universe is moving. So if you have, and so what this statement introduces that, like, we send a rocket ship into space. Obviously, we're the one staying still and the rocket's moving. But from the rocket's point of view, they're staying still and everything else is moving. This is how you end up being able to harmonize all the physics and make some very powerful predictions, like E equals MC squared comes from all of that. But you start to run into some things that are hard to reconcile and hard to square away when you do deal with things like, if we send a rocket ship and then it comes back, that person is only aged a little bit because moving clocks run slow. And then here on Earth, we age like 1,000 years and we're dead and everything by the time they come back. But if the rocket ship thinks we're the one moving, or like person A thinks person B is moving, but person B disagrees, like, how does it all square away? What squares it away in the mathematics is the act of acceleration, is the act of turning, which is a form of acceleration, is the act of slowing down and speeding up. Any time you change your reference frame. That is the key here in special relativity. Anytime you change your reference frame, you introduce a reconciliation in the math. That once you commit to the act of changing reference frame, like let's say you travel away from the earth, but then you stop and then you turn around and then you come back, you are changing your reference frame. In your example, Alan, you had person A and person B, and then like person A is the one who decides to change their reference frame. Once that change of reference frame occurs, all the little mathematics, and it's cool to see actually how this works out in the mathematics. And to enable and help us guide in the mathematics, we use something called space-time diagrams to help us chart the course of what happens with like light signals. When everything's just moving and everyone's in their own reference frame, there's little bits of the math that hitch along for the ride. And then when the reference frame changes, those parts of the math come to life and activate and actually tell us and give us the reconciliation that we need so that everything ends up square in the end. The ultimate lesson, though, is when you change reference frames, you force a reconciliation so that people do get to decide which one was the moving one and which one was the stationary one, because one of them commits to an act of a change of reference. Awesome question. I do have a tiny bit more time, and I'm going to do it. No, am I going to do it?
Hi, Paul. If a black hole is in a binary system, does the event horizon get distorted by tidal forces? And can this tell us anything about the internal structure of the black hole? Thanks.
Oh, awesome question. Yes, black hole event horizons can get distorted. They are subject to, say, tidal interactions. They are subject to deformations and stretching. And yes, by studying how event horizons deform, they don't necessarily tell us about the interior of a black hole, but they do allow us to test our theories of black holes. They allow us to test our understanding of black holes at the event horizon. And this is done exquisitely with things like LIGO, the gravitational wave detector, that measures the collision of black holes. And when they are in the moment of collision, they do stretch out, they do kiss a little, and that affects the gravitational ripples that go out through space-time and the ultimate signal that LIGO gets. So that all matters. And we are able to test it. We are able to detect it. We are able to measure it. And it does tell us something about how the universe works. I'm Paul Sutter, and this is Space Radio. I got to take a break. I know, guys. I know. But this show is brought to you by you. Please visit patreon.com/pmsutter to learn how you can keep the show going. I did 2 questions. I actually did 2 questions. I'm very excited. Are we living in a black hole? No. Space cadets, I hope you're hungry today. I've got good cheese waiting for us. I guarantee it. You're gonna like it. You're gonna like it. All right. Welcome back, everyone. I'm Paul Sutter, and this is Space Radio. We've got more amazing questions ready to go, but remember, you can join the conversation by leaving an online voicemail or by following the live streams. Check out spaceradioshow.com for all the links. We have so many Space Cadet questions launching today. It is not even funny. It is intense. It is getting hot in here tonight, and I am all for it. And we've got Edward Hinton over on YouTube getting us started. What if we find life without DNA? Would it still be life? Well, I'm the wrong person to ask, because I'm not a biologist, I'm not a geneticist, I'm a physicist. So I will give you a physicist answer, which is, if we find life without DNA, would it be life? Well, if we find life, we are defining it to be alive. Be alive. And so therefore it's life and it's tautological. Now that is a very annoying answer that I'm going to own up to. So I'm going to guess that what you meant is, what if we see something that looks like life or resembles life, but doesn't have what we recognize as the basic structures of life. If it didn't have DNA specifically, if it had some other combination of chemicals to manage somehow some genetic code, I think we'd get over that pretty easily. If there's some other mechanism that we haven't even thought of storing and transmitting genetic information, it'd take us a lot longer to get there to convince ourselves it was life, but eventually we would. But if there's like no genetics, there's no transfer of information, there's no storage of information, if there's like nothing, and then if it's not even like doing anything that we would recognize as alive, well, then we could have this argument about rocks. Are rocks alive? I don't know. It's a very fun question to ponder. I do not have a good answer for you, unless you were to ask, like, could we eat it? And then I'd be first in line. I'm going to be honest with you. I'd be first in line to eat alien life. I'd give it a shot. I don't really care what it's made of. As long as it's not poisonous, as long as it's not going to immediately kill me or, slowly and agonizingly kill me, I'd give it a shot. You have my word on that. Edward Hidden again. If we're the only life, you're thinking about life a lot. I like it. In the universe, what's the point in the other 99.9999% of space we will never visit? I don't know. I didn't make the place. I just study it. It's up to you to make the point in the universe. It's up to you to find the meaning. No one's going to hand you meaning. They're just going to say, hey, Ed, here's all the meaning of life. Here it is. Here's why you only occupy a small volume. Here's why most of the universe is void. No one's going to tell you that. No one's going to tell you why. So that's the cool part. You get to make the why. You get to create the meaning. What is the point of the vast majority of the volume of the universe? I don't know. You tell me. Gives us something to look at. Gives me something to study. Gives us something to talk about. Gives us something to think about. Takes up room. Maybe without the space, we couldn't have the stuff. You get to pick the meaning in life, and I think that's the cool part. Orson Zed is asking, if dark matter doesn't interact with itself, how does it form galactic halos? So you got a galaxy. When you look at a galaxy, all those stars and nebula and gas and all the pretty stuff, you're missing most of the stuff. Most of the stuff in our universe is made of dark matter. It is a form of matter invisible to light. It just doesn't interact with light. When you look at a galaxy, it is embedded in a much larger clump known as a halo. Now, one of the properties that we suspect dark matter has, by the way, we don't know what dark matter is. We don't know what it's made of. We're generally confused by it. But one of the properties that we suspect it has is that it doesn't like interacting with itself. And so Orson is asking a question. If it doesn't even talk to itself, how is it able to clump up? Why isn't it just like zoom all over the universe doing whatever it wants? The answer is gravity. Dark matter does interact with other matter and with itself through gravity. Still has mass, and mass causes the bending of space-time. Bending of space-time tells other particles how to move. That's the story of gravity. So through gravitational interactions, dark matter can clump up to form halos, subhalos, big giant halos, and then vast empty regions. It's through the actions of gravity. Dark matter does interact with itself, but through gravity. So it takes billions of years to build structures in our universe, but our universe has plenty of time. A Kento on YouTube. Paul, have you ever heard about this recent study about geodes? Geodes stand for generic dark energy objects that look and act like black holes as predicted by Einstein, but might explain voids in universe expansion. Okay. I'm not going to talk about geodes specifically, but people come up with all sorts of cool ideas. We don't know what dark matter is. We don't know what dark energy is. Like, we have a few mysteries of the universe. People, and by people I mean theoretical physicists and astronomers, come up with all sorts of wacky ideas to explain stuff. It's very, very easy. And we have like a vast network of observations that support this picture, like evidence going back and forth for decades. It's just like all sorts of observations at all sorts of wavelengths. Is like we have a lot of data. And when you take a small subset of that data, when you just say like, I'm going to pick this observation and this thing and this one thing, you can find a theory that fits it. You can make up a new theoretical object that explains that. But then your job's not done. You have to explain the rest of the observations, which is where a lot of wacky ideas run into some serious sticking points. Because to explain a subset of our observations is relatively easy because you just tune a model and design some crazy ideas to fit that set of observations. But then when you go out to the whole hog and try to explain all of modern cosmology, you run into issues. So geodes fit into that. They are designed to solve certain problems, but are not good at solving all problems in cosmology and not agreeing with all observations and agreeing with all data. So they're designed to like solve a problem, agree with some set of observations, but then they run into trouble with other observations. And that's just the way it goes until someone hits upon an idea, or what more naturally happens is a lot of people work towards a consensus idea to explain all data and move the field forward. Are geodes going to move the field forward? I'm sure they're an interesting idea. They're cool to think about. They might teach us something useful. Are the explanation for dark energy, the expansion of the universe, of cosmic voids? Not, I don't think so, because they're designed to explain some set of observations and not others. Anyway, we're almost out of time on Space Radio, but before we go, it is time for the blue shift. Man, that was fast. Thank you, Kento, for a really cool question. DRD, what's up with Mars? I don't know. Mars is overrated. I'm going to do a special video next week called Mars is Overrated. You should check it out. I'm Paul Sutter, and you're listening to Space Radio, and this is the Blue Shift, my opportunity to get a little bit closer to you. 3 years ago, which seems like yesterday, I went on a little experiment with the crew at WCBE 90.5 FM in Columbus to make a radio show about science, about astronomy, about physics, and make it focus on the audience. Allow people to call in, allow people to ask questions, and I would respond freely to their questions. So it was like car talk, but for space talk. That might have been a better name for the show, but it's too late now. We built that airplane as it was flying, slowly adding in the online element, figuring out the best way to do a voice messaging system, setting up the camera and the lights, and like getting a process going. And we had a really good show. I went in every Thursday afternoon at 4 p.m. to the station, set up the gear, plugged in my computer, and we did a live show. And then a year and a half ago, I moved from Columbus, Ohio to New York City to keep pursuing my work in science outreach and communication. Since then, we've done the show remotely, where I record it live, just like I did, but instead of being in studio, I was in my home office, and I would send the files to my producer, Greg, who would edit it and put it on the air. And I decided early on I wanted the show to be live. I wanted people to be able to call in and interact and have conversations. We tried that 3 years ago with the calling in live. That didn't work out so well, just for a bunch of technical reasons. And then I hit upon this idea of this doing a live stream and then later releasing the show as both a podcast and as a radio show. I recently made the decision to end the audio portion of this show. So what this means is that Space Radio is still a thing. Thursdays, 8 p.m. Eastern, I'm going to be right here behind my microphone in front of the camera with one random light set up in my home office and my computer here filled up with space cadets throwing questions at me as quickly as they can. And Nancy Graziano doing her best to keep up with it. But what I was not going forward is the audio version of that show to be released as a podcast and to be released as a radio show. So if you listen to Space Radio on the radio on WCB 90.5 FM, I can't thank you enough for listening and for tuning in. Please keep supporting the station. If you love this spacey talk audio goodness, I encourage you to listen to my podcast called Ask a Spaceman. There is an archive of over 100 episodes, and I'm still doing more. I release 2 episodes every month. That's askaspaceman.com. If you really, really do like this interactive discussion, then tune in Thursdays at 8 p.m. Eastern. You go to youtube.com/PaulMSutter/live or go to spaceradioshow.com for the link, and you'll be able to tune in live. Also, I am keeping the videos up on YouTube, so you can always visit past episodes. You can always listen to them and watch them that way. So I'm keeping, don't worry, Space Radio will exist, but I've decided to end the radio show and to end the audio podcast. So we are going to live in video land. One of the reasons I wanted to do this was that I'm trying to do everything at once with this show, which is create a compelling live show for YouTube, but then also a show that makes sense for podcast and radio. And over the past year, especially as I've been doing this on my own, I feel like I'm doing neither of those well. And I should focus, and I decided to make a focus on the live show. So going forward on the YouTube live stream, there will be more visuals. We won't need to take commercial breaks. We won't need to be timed. It can be more casual, and there's time for more questions. There's time for like interviews and watching video clips online. And so that's the direction I'm taking the show. I can't thank you enough for your support of 3 years on the air at WCB 90.5 FM. I can't thank the team at WCB 90.5 for creating this show, making this show happen, making that airplane, building it as we were flying it, continuing to support the show even after I moved to New York a year and a half ago. And just keeping that dream alive. WCB 90.5 FM will always have a place in my heart. Greg will also, my producer Greg will also always have a place in my heart. The doctors call it cholesterol, but I call it Greg. So thank you for listening, and I'll see you out there. And unfortunately, this broadcast is almost done. Thank you for joining me on this voyage of Space Radio. Once again, I'm Paul Sutter, and this show is brought to you by you. Visit patreon.com/PMSutter to learn how you can contribute. Thanks for everything, Greg, Dan, all the crew at WCB 90.5 FM. Again, if you listen to this on the radio, please keep supporting the station. Thank you, Nancy Graziano, for continuing to wrangle the Space Cadets and all the fine crew for making this show possible. Catch the live stream every Thursday at 8 p.m. Eastern. That's right, next week it's going to be on. Go to spaceradioshow.com for all the links, live stream locations, places where you can leave a voicemail, my social media stuff. Thank you, Space Cadets, for listening. See you next week. And remember, science is for sharing. I hope we never forget that. End of transmission. Don't go anywhere, Space Cadets. That was the end of the radio broadcast, and that was the end of Space Radio on the radio. Now Space Radio should I call it Space Video? Oh, that's right, Ed. And you know what? I'm still going to bring in Greg every week. Cheese is also for sharing. Oh gosh, are you guys ready for this, Cheese? I thought of something because I knew this was going to be a special day. The last broadcast of Space Radio. Nancy, I saw you asked about my finger. I just cut it in the kitchen, and it was not a cheese-related incident. It was just a pretty nasty cut, and so hence this guy. Spacecast, isn't that taken? I think I'll keep the name Space Radio. It sounds cool. And I still want to open the show every week with Live from Earth at Space Radio. But this cheese is something special. I talked to Greg's mom, and she told me Greg's favorite cheese. So and actually I'm going to bring Greg back. Greg, I know you're listening to audio. You should check out the YouTube. It looks like you're dead This picture of you looks like the in memoriam picture, you know, like, we'll always remember you, Greg. 1911 to 2020, whenever you were born. I'm going to keep it going, I think, because it's just too funny. But I talked to your mom, and I got your favorite cheese, and I wanted to celebrate with you. I got Cheese Whiz. Well, it's not technically Cheese Whiz. It's Easy Cheese. This is an Nabisco brand. I don't know if it's the same thing. What happened to the Cheese Whiz brand? I had 2 flavor choices available to me on the shelf: cheddar flavor and American flavor. I went with the cheddar flavor. There it is, Easy Cheese. Some of you may be watching. Wondering what the heck is this? It's cheese in a can that you spray onto food or directly in your mouth. The choice is yours, and it depends on who's watching. So you don't need to shake it up. It is like, you know, I read the labels to you, and they talk about like, oh, this region of France. So we made the no, this is contents under pressure. Do not puncture or expose to excessive heat. No need to refrigerate. That's what you want to know from your cheese. Number 1 ingredient is whey. And then canola oil, milk protein concentrate. It's got some other things, enzymes, sorbic acid. This is intense. I don't think I shake it. I don't feel it's not like Nancy. This is Cheese Whiz. No need to. This is, guys, if you've never had this, I brought some crackers. I got like little pretzel crackers here. If you've never done this before, like, this is my childhood too, and it's Greg's favorite cheese, still is today. You just come out, it comes out, it has the oddest texture like you could possibly imagine, because it holds its shape unless it gets really, really hot out. And of course the tip is like fluted, or, you know, has like little grooves in it. Can you see that? Wow. Yeah, canned cheese. And then that brings me back. I don't know what flavor that is supposed to be. It tastes like tangy rubber. Like a very tangy, milky tire. And I'm pretty sure that's how it's made. And you just, oh my gosh, and you just see it. It looks like a little worm, but then you know what? The crazy thing is, yeah. And even though it's terrible, even though it is disgusting, it's also good. It's salty, creamy, rubbery, gooey. Like, if there is a species of worm that tasted like cheese, I'm pretty sure this is what. But you just do it. Look. Like, I'm like talking about how horrible it is, and then you just spread more on. No, I'm not. No, Edward, I'm not high. Nope, not for me. It's just Cheese Whiz, and I'm just having fun. Greg, this one's for you.